From the Spec Network, this is Fragmented, an Android developer podcast where we talk about building good software and becoming better Android developers. I'm Don Felker.
And I'm Kaushik Gopal.
Welcome to the show.
How many of you saw the Flutter Live event held in London on the 4th of December 2018? Google announced Flutter 1.0. We've talked about how awesome it could be building apps with Flutter, but at the same event, a startup in Estonia partnered with Google to announce a brand new CI and delivery service tool called CodeMagic. This startup is Nevercode, and Nevercode built CodeMagic. Today, I'd like to thank them for sponsoring this show. CodeMagic is the first CI/CD tool created exclusively for building Flutter applications. The idea for them was, without any deep technical knowledge, app developers like us should be able to easily configure the whole flow for the Flutter platform to the users of our app on the Play Store or App Store. Because remember, with Flutter apps, you can easily build both Android and iOS applications. It's a cloud-based CI/CD tool for building, testing, and publishing Flutter apps. Users log in via GitHub and select the repository containing their Flutter application, after which they can immediately start a build with pre-configured defaults. Even the folks at Google working on Flutter have had great things to say about this. For example, Tim, the group PM for Flutter, said this: Nevercode has a really good understanding of the workflow that Flutter developers want. Their CodeMagic product takes all the pain out of the build process. That's pretty cool. So if you're a Flutter dev, build, test, and publish your Flutter apps in record time with CodeMagic. Go ahead and check them out at codemagic.io. But here's the kicker. For the time being, the tool is available to everyone at no cost because they just announced it. It's totally free. But in the future, it probably will include paid options in addition to the free plan. So you should check them out while they're still hot from the presses. Thanks for sponsoring today's show, Nevercode. At Instacart, we were building for offline mode in our app, and a product manager once came up to me and asked a very deceptively simple question. Hey, do we track our network requests? How many of those requests sent from the mobile client actually even make it to the server and back successfully? What's the best way to do that? Sure, it's easy enough to maybe log a network exception if you get it on Crashlytics or, any of the other telemetry platforms that you use, but network errors could come from multiple fronts. It could be that the client had problems reaching the server. It could be that the server had problems. For example, if your backend was down for some reason. It could also be that the server received the request but just couldn't fulfill it. Like a 500 internal server error. It could also be that the server received the request and sent a response, but the client missed the response, maybe because the client was unreachable for some reason or went down. There's multiple points of failures for that originating network request. Wouldn't it be nice if we could just have a single ID that tracked this request all the way from the beginning, right, till the end to our response? That, my friends, is where we enter the world of HTTP request headers, specifically the X request ID. By adding a special header in your network request, you can easily trace an HTTP request all the way from client to your backend web processes. Today, we're going to be touching a little on these fundamentals, but I think as experienced mobile developers, it's always important to have these concepts and some of these ideas down. Fundamentally, the idea is pretty simple. Each time a request is made from your app, a new request ID is generated. Typically, this tends to be a UUID, and you can track this somewhere in your app logs. This is then sent along with the HTTP request to your application's web process. It's sent in the HTTP header. If you don't know what this is, I'll again drop a link in the show notes. Definitely read up on that. It's just good to know how the web works in general. So it's sent via the header in our HTTP request. This typically hits a reverse proxy or probably a load balancer. We log the network request that is sent at this stage as well. Now, given that the header already has that request ID we sent, it's easy to actually sort of correlate this, right? So you can correlate the requests in the proxy to the requests that finally also then hit the application. So With this, we actually have a chain of tracking for each of those network requests. And because we use the same ID throughout, it becomes pretty easy to track these requests from start to end. The Rails framework has standardized this header to be named X request ID. So it's X-request-ID. But it's also referred to as just request ID in some other backend application platforms, and also X correlation ID for the same correlating reasons we mentioned before. A small aside for the folks who have heard of this before. Did you ever stop to think why there's an X hyphen with all these HTTP request headers as a prefix? Well, I was curious, so I searched for this, and according to Wikipedia, apparently a lot of these header fields were non-standard. So the standard at the time was that for non-standard header fields, they were conventionally marked by prefixing the field with X hyphen. So, that's where the prefix comes from. But this convention was deprecated in June 2012 because of the inconvenience it caused when non-standard fields became standard. I found that to be funny. All right. So we're Android developers here. And the obvious question that comes from this whole X request ID thing is, okay, how do I generate these? And secondly, how do I send these up? Now, this would again depend on how you do your networking and which library you use. Most of us today use the library OKHTTP for Android networking, and you retrofit for further convenience. So I'm going to be focusing on this. In OKHTTP land, a simple and recommended way to add headers to all your network requests is by using what is called an interceptor. Now, I'm not going to go into the basics of what interceptors are. Again, I'll drop a link in the show notes to the wiki page that does a much better job of what I can do with words. But it's pretty much what the name suggests. You can intercept requests in your app before they're sent out. So in your interceptor, when you're building the request, you can also make sure to pass in any information that you want. So in our case here, in the HTTP header, what you're going to do is you're going to send the header key X-request-ID. And now the important question comes up. What do I send as the value? The value is basically just a unique UUID for every single request. The standard is basically to just send a UUID. And in general, UUIDs are great IDs to use versus, something like a monotonically increasing integer. If you're curious why UUIDs are good, hit us up on Twitter or Discord, and we'll try to do another fragment on that independently. But on Android, it's super straightforward to basically generate a UUID. It's been available since in the OS since I think API level 1. So you just do uuid.randomid.toString and boom, you basically have your UUID generated. That sums up pretty much how you would do this. Now, a good question to always ask is, wait, network request tracking, could I be violating user privacy in some ways? In today's day and age, that's a great question to ask, but I don't think it violates user privacy because firstly, the ID is a UUID, which is completely randomly generated by the client. So it holds no sensitive information about the user. From that UUID alone, basically you can't tell anything about the user. And also, the important point here is a unique ID is created per request. So there's no sort of pattern here that users can figure out saying, oh, this kind of UUID will be sent for, payment requests. And so you basically can't tell from that UUID. Also, do make sure you check to see with your backend folks what is supported. For example, Don and I are big fans of the Rails application framework. And in the Rails platform, if you don't send up explicitly this value, if you don't send up this header value, X-request-ID, if you notice in the response, they automatically generate this request ID on right from the point that it receives the request and sends that down to the response. So it's almost nice because if you actually do send that value from your mobile app, it sort of uses the value that was provided by the client. And then that's how you can basically link all these steps together. That's it for the show, folks. I thought this is a nice quick tip that I'll throw your way. I will catch you in the next episode. And before we wind this show down, I also want to thank Nevercode for sponsoring this show. specifically their brand new cloud-based CI/CD tool called CodeMagic. They partnered with Google and released the very first CI/CD tool exclusively for building Flutter apps. Build, test, and publish your Flutter apps in record time with CodeMagic. Check them out at codemagic.io while the service is still available to everyone for free. My thanks to Nevercode again for sponsoring the show. That's it for the show, folks. Fragmented is hosted by Don Felker and me, Kaushik Gopal. We edit and produce all the episodes here on Fragmented. Sarah the Amazing Jackson from the Spec Network helps with production assistance and wraps our final mix. Our theme and ad music is by the national recording artist Blueprint from Weightless Recordings. You can find more Fragmented episodes at fragmentedpodcast.com. Thanks for listening, and we will catch you in the next episode.